Hi everyone. In this episode, we'll be looking into how to convert binary to denary. In the previous episode, we spoke about how to convert denary to binary, and now we'll be looking how to convert binary to denary. Before we start converting, let's see what what is the technique we're using to convert binary to denary. I'll be breaking it down and showing it in denary terms, and then show we'll be looking into how place values work, and then we'll be looking into the binary then we'll be stepping into the binary conversion. So I will take a simple example. I'll be taking a simple example. For example, let's say I'm taking the denary value 8947, and this is a denary value, right? So when we look at it, we 8, 9, 4, and 7 is basically we call this ones, tens, hundreds, and thousands, right? And we can go we continue so that we say 10,000s, 100,000s, and so on, right? So this is one. That means here the place value of 7 is 7, right? And the place value of 4 is 40, right? Place value of 9 is 900, and 8 is 8,000, right? So that is how denary works, right? And also if we look at it, uh, here 10 is, since this is a denary number, right? We get 10 to the power 1, 10 to the power 2, and 10 to the power 3, right? And 10 to the power 3, 10 to the power 2, 10 to the power 1, and this 1 is actually 10 to the power 0. In maths, we learn that 10 to the power anything, actually, anything to the power 0 is 1, right? So when we get the value of 7 over here, that means in the ones we have 7, and 4 times 10 we get 40, and 9 times 100 we get 900, and 8,000 we get 1000, 8,000, and then when we add them together we get 8,947. The reason I showed you this is the same technique that we are using in binary, but instead of having tens we have twos. That is the only difference. So, and this is the same way we'll be using to convert even hexadecimal to denary, right? Now this time I will take a binary number for an example. Let's say 11001010, right? For the exams, most of the time you will be getting only up to 8 digits, right? But just in case, be let's be prepared for anything. So I'll just add another 2 ones at the end, right? So the first thing we are going to do is write them apart, right? 1 1 0 0 1 0 1 0, right? And then starting from the right, side, I'll be marking their place values, which is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6, and 2 to the power 7, right? And then 2 to the power 0, anything to the power 0 is 1, right? And then what we do is you don't need to remember this actually, right? We start with 1, we multiply it by 2, it becomes, we get 2. And then 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 2 64 times 2 is 128, right? You don't need to remember this in your head because uh, like you don't need to study that 2 to the power 4 is 16. You don't need to keep that in mind because starting from the right side, you mark the 2 to the power 0 and then just put the 1 and then keep on multiplying by 2. That is the best way we can do this. And also the values at towards the end, actually the 2, 4, 8, 16, 32 is actually the sizes of storage that we use most of the time. Like if we take RAM sizes, we get 8 GB, 4 GB, 16, 32, 64, and so on. Right? More like the amount of RAM or even storage devices, but mostly RAM, we get those amount of storages. Right? All right. So now what we do is we multiply this by this. Right? 0 times 1 is 0. 1 times 2 is 2, 0 times 4 is 0, 1 times 8 is 8, 0 times 16 is 0, 0 times 32 is 0, 1 times 64 is 64, and 1 times 128 is 128. Right? Now what we do is we add this value. Right? When we add them together, we should be getting the denary equivalent of this one. So what I won't be adding it horizontally, so I'll be writing it in a side 124, 64, 8, and 2. So what I normally in my experience, I group them by 10. So here we have 8 plus 2 is 10, 8 plus 4 is 12, right? 12 plus 10 is 22, 2, carry the 2, 2 plus 2 is 4, 4 plus 6 is 10, 0, carry the 1, 1 plus 1 is 2. Here the math is actually the way you are doing it uh, is totally fine. It's just this is my way of doing it. You can make your own way. But this method is the same, right? And then we get 202 in denary, right? So this is how we convert the numbers from binary to denary. So now let's look at a few more examples just to make sure that we get the whole thing, right? Let's say 1100, 1100, 111, right? I added a little bit extra numbers this time, right? Again, write them apart, 1100, 1100, 111, right? So again, you don't need to write this time. What we'll do is again this is the full method, right? For your understanding, right? After this one, I will show you some shorter methods that we can use, right? Removing certain steps that, and then we can do it quicker, right? But this thing, the way, if you can actually we should actually understand this in order to do them. So that is the reason I'm showing you how to do this first, right? 2 to the power 0, it always starts from 2 to the power 0, which is 1, right? 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, and 2 to the power 10. Then we write the values of this. Start from 1, always starts from 1. Then multiply that by 2, 2. You don't need to remember, like I said again, you don't need to remember 2 to the power 2 is this much, 2 to the power 3 is this much, 2 to the power 4 is this much. Instead, let's start from 1, multiply that by 2. Multiply that by 2, we get 4. 4 times 2 is 8, 16, 32, 64, 128, 256, 512, and 1024, right? When you multiply, you get these values, right? Again, I don't recommend keeping them in mind like 2 about 10 is 1024, but again, it's your preference, right? Then what we do is we'll be multiply them this by from the first this by this, right? We get 1, 2, 4, 0, 0 times 16 is 0, 1 times 30 is 32, 64, 128, 250. Sorry, here we have a 0, so we get 0, 0, 512, and 1024. Now, to get the denary value of this, we need to add these together, right? See, all right. So, 1024, 512, 64, 32, 4, 2, 1. Like I said, I said that I'll be grouping this by 10. So like this, right? This is my method again. You can do your own way. I Here we have 4 plus 2 plus 4, we get 10, right? And then here we get 2 plus 4 plus 2 is 8. 8 plus 1 is 9. So here we get only 9, right? Here we have 10. 10 plus 9 is 19. 9 carry the 1. Here 1 plus 2 plus 1 is 4. 4 plus 6 is 10. 10 plus 3 is 13. 3 carry the 1. Here 1 plus 5 is 6, and we get 1639. 1639 denary. I hope you understood this method, right? This is how it works. This is how we convert it. And now um, let's look at another way we can actually it's like this. What we are doing is we are going to remove steps from the calculation. That's all, right? For example, I'll be taking 1010 1100, right? So, and I'll add another one, right? So again, write them apart: 1010 1100 1, right? Instead of writing the two to the powers, right? Let's skip that part. We'll be writing the values. Start from 1, 2, 4, 8, 16, 32, 64, 128, and 256, right? Then we multiply this by this: 1, 0, 0, 8, 16, 0, 64, 0 times 120, 0, and 256. So we add them together. So this time we didn't write the 2 to the power values in this case, but still the answer is the same: 256, 64, 16, 8, 1, right? Here we get 10, 6 plus 8 we get 14, 14 plus 10 is 24, 24 plus 1 is 25, 5, carry the 2, we get 5 plus 2 is 7, 7 plus 1 is 8, 8 plus 6 is 14, 4, carry the 1, 345. Here we get 345 in denary. Alright, now we are going to simplify this a little bit more, right? Now you can see here we have the same set of numbers, but only difference is that here 128, when this will be 0 when this value is 0, right? So again, I'm going to simplify this on this a little bit more, right? And then we get 1100. I'm not sure why I'm going with the 1100. Maybe it's stuck in my head. So I'll 110101, right? Again, write it apart: 1100 110 101. Now this time we are going to do the 1, 2, 4, 8 thing, but when it's a 0, we write it on the top of the number like this, right? 1, 2, 4, 8, 8 because it is a 0, we put it on top. 8, 16, 16, 1 is, if it's a 1, put it on the bottom. 16, we multiply this by 2, we get 32, 32, multiplied by 2, it's a 64 because it's a 0, we put it on top. 64, 64 multiplied by 2, 128, and since the 128 multiplied by 2 is 256 and 512. Right, now we add this value. So what we had done, only thing different we had done is we have wrote all of these numbers, but when it's a 0, we just wrote it on top so that it doesn't come in uh, come into play, right? 512 plus 256 plus 32 plus 16 plus 4 plus 1, right? Here we get 10, 6 plus 4 we get 10, and we have 1, we get 21. 1 carry the 2, 2 plus 1 is 2 plus 1 plus 5 is 8, 8 plus 3 is 11, 11 plus 1 is 12, 2 carry the 1, 8, 821. So this value is 821 in Denary. So this is basically the uh, let's call it the shorter method, right? Let's do another question like this, another one like this, so that you can understand. So actually, I'll do all both methods so that we have a comparison, right? The first method that I showed you and the last method that I showed you. All right. Let's see 1 0 1 1 0 1 0 1 0 0 1. Right? Again, we'll be writing it apart. 1 0 1 1 0 1 0 0 0 1 0 1 0 1 0 0 1 1 0 0 1, right? Then 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, and 2 to the power 9, and 2 to the power 10, right? All right, now what we are doing is we are writing the values 1, starting from 1, then multiply that by 2, 4, 8, 16, 32, 64, 128, 256, and 512, and 1024. Right, now we multiply them by this value and this value, that means top value and bottom value. 1 0, if it's a 0, definitely anything multiplied by 0 is 0, so we get 0 0. 1 times 8 is 8, 0, 32, 0, 128, 256, 0, and 1024. Now we add them together, get. All right, so I'll be doing the addition in the side. 1024 into 512 into 256, add 128, 32, 8, and 1. All right, so here we get, here this 2 and 8 we get 10, here this 2 and 8 we get 10, this 6 and 4 we get 10, so we have 3 10s, so 30, 30 plus 1 is 31, 1 carry the 3, 3 plus 2 is 5, 5 plus 3 plus 2 is 5, 5 plus 5 is 10, 10, 11, 12, 13, 14, 15, and 16. 6, get the 1, and then we have 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 5 is 9, 9, and 1. 1961 in Denary. Is that clear? That is the first method that I showed you. Now let's look at the uh, other method that I showed you. Again, write it apart. 1 0 1 1 0 1 0 1 0 0 1, right? So 1 2 4 8 16 32 64 128 256 512 and 1024. Right, now we add them together to get 1024, 1024 plus, I'm pretty sure, okay, 1024 plus 256 plus, sorry, did I make a mistake? Oh yeah, I made a mistake in this one. Here we don't have 512, right? Okay, yeah. So in the previous one I made a mistake, so let me correct it. So we won't be having this 512. So uh, let's do the calculation again. 256 plus 128 plus 32 plus 8 plus 1. Here we get 10. Here we get 10. Here we get 9. 10, 20. So we get 10 plus 10. 10 is 20. 20 plus 9 is 29. Carry the 2 here. 2 plus 2 is 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4, carry the 1, and we get 4 here and 1. So instead of 1961, we get 1449 in denary. 1449 in denary. Right? Since both the values are the same, we don't need to calculate it again. Alright, so these are the two methods that I showed you, right? I hope you understood. If you have any doubts, you can always contact me, or you can drop me an email, or you can drop a comment. Alright, so this is it for this video, and in the next video we'll be looking into how to convert uh, denary or decimal into hexadecimal, and then after that we'll be looking into how to convert hexadecimal into denary, which is actually the same method, but we won't be using any short methods, just the classic method, because for the exams you will be getting only very few, like 2 to 3 digits maximum, or rarely 4. So we'll be looking into that. All right, so this is it for this video, and I'll see you in the next one.